Hi everyone, welcome to your first day of instruction in AP Calculus BC. I hope that the week that you spent going through last year's FRQs was helpful and reminded you of some things that maybe you'd forgotten over the summer. As I reminded you on the first day of the year, I am not spending, for example, the first 9 weeks reviewing all of the AB content. There are a lot of Calc BC programs out there that do that, that spend a lot of time at the beginning of the year reviewing AB, but I choose not to do that because I like to assume that you have a little bit better retention than that, and I like to review topics as they become relevant or as they become important. And so, for example, we're beginning a unit on advanced integration. That's your first unit in this class. And so I'm going to review some integration techniques with you. This is not the order that you learn things in Calc AB, but I'm going to review them as they come up. Okay, so for example, in the next unit, we're going to do some stuff involving limits. So I'll start by reviewing limits briefly with you and then diving into the BC topics. All right, so today's lesson should be something that you're comfortable with. We're going to review U substitution. And so I'd like you to please take a minute and do this warm up. I want you to evaluate this indefinite integral. Please pause the video and take 2 to 3 minutes to evaluate. Okay, so hopefully you realized that this was a U substitution problem. And I see that my inner function here is x squared plus 9. That quantity is cubed. And I notice that the derivative of that quantity, or at least a multiple of the derivative of that quantity, is also present in this integral. So I'm going to define my U as x squared plus 9 and my du as 2x dx. And I notice that this comes out really nicely in terms of substitution. 2x dx becomes my du, x squared plus 9 becomes my u, which is cubed, and I'm left with the integral of u cubed du. If I integrate that, I bring u cubed up a power, which makes it u to the 4th. I divide by that new power, which puts a 1/4 out front, and since this is indefinite, I need to remember my plus c. Okay. Now I need to go back from u's to x's, and so I get 1/4 times the quantity x squared plus 9 raised to the 4th power plus my constant of integration, and that is my answer. So I hope at this point you understand that you can take the derivative of pretty much anything. Assuming that you know how various functions work, you literally can take the derivative of anything. However, integration is limited. Not everything has an antiderivative, okay? And you in particular are somewhat limited in your abilities to integrate because all that you have, other than backwards power rule, is U substitution. Okay, there are other methods of integration, which is what I'm going to cover in this unit. So we're going to start today by reviewing U sub, and then later in the week we're going to move into more advanced BC methods, which include integration by partial fraction decomposition and integration by parts. On Friday, you're going to have a quiz on all of this. Okay, so that quiz is going to cover U sub, it's going to cover partial fraction decomposition, and it's going to cover integration by parts. So today's lesson is really just a ton of examples of U substitution. I'm going to let you all decide as a class how this would best benefit you. If you'd rather watch a couple of examples first and then start doing the examples on your own and playing the video to check your answer, that's fine. In fact, I think that's probably what I'd recommend. If you'd rather just start by doing these on your own and pausing the video each time and having me go over them, then that's fine too. So actually pause the video for just a second to discuss as a class how you want to do this. Okay, by the way, what I don't want you to do is just watch me work through every single example. There's no point to that. I need you guys solving these and seeing where your misconceptions are. So at this point, either pause the video, work this one out, play it to check your answer, or follow along as I solve this one. This is also u substitution. I'm going to define u as 7x plus 7. Therefore, du is 7 dx. I notice there is no 7 dx to account for my du, so I'm going to throw a 7 in here somewhere, wherever I can fit it. There's my 7. And that 7 needs to be balanced by a 1/7 in front of the integral. So now this is 1/7 times the integral. 7x plus 7 becomes u is to the 5th power. 7 dx becomes du. And now this is pretty similar to our warm-up. 1/7, I integrate u to the 5th, and I get 1/6 u to the 6th plus c. And if I simplify all of this, I have 1 over 42. U is 7x plus 7. That's raised to the 6th power, plus my constant of integration. Next example, either pause and work it out and then watch my solution, or for this one and maybe one more, you can just follow along. Again, I notice I have some quantity raised to the 4th power. Then I have something else out here that's not a constant but is linear. However, I notice that if I assign u kind of the way I want to, 3x squared plus 10x, and I just go ahead and test and see what du gives me, 6x plus 10. 6x plus 10 is a multiple of 3x plus 5. If I take 3x plus 5 and I multiply it by 2, I get 6x plus 10. So this actually works. I just need a 1/2 out front to balance. So this becomes 1/2 times the integral of u to the 4th du. And this becomes 1/2 times 1/5 u to the 5th power plus my constant of integration, which if I go back from u's to x's, I have 1/10. U is 3x squared plus 10x, all to the 5th power, plus my constant of integration. All right, either pause the video and work this out and use my work to check your answer, or this is the last one I'd like you to just passively follow. After this one, I really want you guys working these out on your own. By the way, when you work these out on your own, by all means discuss with each other, ask each other questions. Working on your own in my class does not mean silence, but it does mean focus. I'm going to define my u as the denominator, well, not the entire denominator, but the inner function of the denominator, which is x cubed plus 3x squared plus 9. And I'm hoping that the derivative of this comes out to some multiple of the numerator. So du gives me 3x squared plus 6x, which, lo and behold, is 3 times the numerator. So I'm going to put a 3 up top, a 1/3 out front, and I'm left with 1/3 times the integral. My numerator now, 3x squared plus 6x dx, is my du, over my denominator is u to the 4th. This is a nice substitution. Everything is in terms of u's. However, I'd really like that u in the denominator to be in the numerator, make my life a little bit easier. Okay, and so when I integrate this, I have 1/3. I bring u to the -4th up a power, which makes it u to the -3, because -4 plus 1 is -3. I divide by that new power, and I add my constant of integration. So this is now -1/9 times u is x cubed plus 3x squared plus 9 to the -3 plus my constant of integration, which is fine. Or the answer may have been written with this having a positive exponent in the denominator. So please make sure you could recognize -1 over 9 and then x cubed plus 3x squared plus 9 to the positive 3rd power, all in the denominator, plus c. All right, let's do some trig. Regardless of where you guys are, I'd like you to pause the video here, work this one out on your own, okay, and then unpause the video to check your work. All right, the first thing I'm going to do, I hate this notation. I hate this 2 there. So I'm going to rewrite this as sine of 3x squared times cosine of 3x dx. This is a lot friendlier for me. And now I can see that this sine of 3x is an inner function. So I'm going to use that as my u. Okay. Du is going to be cosine of 3x times 3 dx. Don't forget the chain rule there. And so I need a 3 in order to justify my du, which means I need a 1/3 out front. So this, upon substitution, becomes 1/3 times the integral. Sine of 3x is u, so this is u squared. 3 cosine 3x dx is du. Okay, so again, this just becomes backwards power rule integration. So I have 1/3 times 1/3 u cubed plus c, which becomes 1/9. U is sine of 3x cubed plus my constant of integration. This one's a little trickier. I want you all to push yourselves and see if you can remember how to do this, because this is one where my du doesn't quite match what's going on out here, and I have to do some extra manipulation. Please pause the video and see if, as you know, kind of small groups of people, you can figure this out. Okay, so I'm still going to assign my u as my inner function, the one under the square root, 2x minus 1. And then my du is equal to 2 dx. Well, I'm a little stuck because there's this x here. And if I just go for straight substitution, I have x square root of u, and then what? Do I keep this a dx? Do I change this to a du with a 1/2 out front? Regardless, I have x and u in the same problem, and that's no good. So hopefully you remembered what to do. I need to take this u definition and solve it for x. So when I do that, I have u plus 1 is equal to 2x. I just added 1 to both sides. Divide both sides by 2, and I have x is equal to u plus 1 all over 2. Okay? And du is equal to 2 dx. So dx is equal to 1/2 du. That might be worth knowing. Let's go ahead back to the original problem and make as many substitutions as we can. X, what can I substitute for x in terms of u? U plus 1 over 2. Square root of 2x minus 1 is the square root of u. I'm going to call this u to the 1/2. And then dx is 1/2 du. Now each x term has been replaced with an equivalent substituted u term. I'm going to take these constants and move them out front of the integral. You don't have to, but I tend to lose constants. So now I have 1/4 times the integral of u plus 1 times u to the 1/2 du. And maybe you got here and got a little bit stuck, but this is just two terms multiplied together. I can distribute this u to 1/2 into the u plus 1 in parentheses. So this is going to become 1/4 times the integral of u times u to the 1/2 is u to the 3/2 plus 1 times u to the 1/2 is u to the 1/2 du. Now I can integrate. 1/4. I bring u to the 3/2 up a power, and I have 2/5 u to the 5/2 plus I bring u to the 1/2 up a power, and I have 2/3 u to the 3/2 plus c. And finally, I can go back and unsubstitute. This is not going to be a pretty answer, but it's going to be correct. I think I'll just keep the 1/4 out front. It doesn't really matter. 2/5 u is 2x minus 1 to the 5/2 plus 2/3 u is still 2x minus 1 to the 3/2 plus c. Not pretty, but it's good. Go ahead and pause and try and solve this one. This one should be a little easier. Okay, so I'm going to define my u as 2x plus 3. And so then my du is 2 dx, which means I need a 2 paired with this dx. which forces me to put a 1/2 out front. I now have 1/2 times the integral. The numerator becomes du. The denominator becomes just u. Hopefully you recognize this. A single u in the denominator when being integrated gives me a natural log. So this is 1/2 the natural log of the absolute value of u plus c. So 1/2 the natural log of the absolute value of 2x plus 3 plus c. Please don't forget the absolute values. Please don't forget your plus c. All right, that was lots of examples. Let's just do one or two that involve definite integrals. What I mean by a definite integral is one in which I have limits of integration. And I'm picky on this. I'm not sure how picky your AB teacher was, but I'm going to need you to perform a change of variables on your limits of integration. I need you to U your limits. And you're going to see later on in the year why I'm picky about this, okay? I'm not going to take off if you don't, but this is really the way I'd like you to do this. Let me remind you what I mean by that. So if I'm integrating from 0 to 2, x squared times the square root of x cubed plus 1 dx, I think I said that right. Let's go ahead and do our preliminary substitution. U is x cubed plus 1. Du is 3x squared dx. So I need a 3 out here and a 1/3 out front. I have 1/3 times the integral of, I'm going to call this u to the 1/2 instead of the square root of u, du. I hope you're okay with that. I also need to u my limits. So u of 0 is 0 cubed plus 1, that's 1. And u of 2 is 2 cubed plus 1, that's 9. So I'm integrating this from 1 to 9 in terms of u. This du means I'm integrating with respect to u as u goes from 1 to 9. Putting 0 here and 2 here is wrong because u does not go from 0 to 2. If you hate uing your limits, then leave off the limits of integration until the end, okay? All right, let's go ahead and integrate. This is 1/3. Bring u up a power and it becomes 3/2 with a 2/3 out front. And guys, when you have limits of integration, the nice thing about uing your limits is that you never return back to x's. You just leave this from 1 to 9. So now this is 2/9 times 9 to the 3/2 minus 1 to the 3/2. If this is free response, you stop here. However, I need us to be able to evaluate this in case of a multiple choice scenario. So this is 2/9. 9 to the 3/2. You do need to be able to do this in your head. The 2 in the denominator means I'm taking the second root or the square root of 9, which is 3. Then 3 cubed, which is 27. Minus the square root of 1 is 1, 1 cubed is 1. And so I'm left with 2/9 times 26, okay, or 52 over 9, and I'm going to be done right there, 52 over 9. Again, if it's free response, no, don't even stop there. Stop there. If it's multiple choice, you better believe they're going to go all the way to a simplified answer. All right, pause the video and evaluate this definite integral, and please do it using your limits. And then when students are done, you can unpause and check your answer. I define u to be x squared plus 1. Therefore, du is 2x dx, which means a 2 out front and a 1/2 in front of the integral. I need to u my limits. U of 1 is going to be 2. U of 3 is going to be 10. By the way, I got this by plugging 1 in for x in my definition of u over here. 3 squared plus 1. Okay, so this integral becomes 1/2 times the integral from 2 to 10 of u to the -2 du. When I integrate this, I have 1/2 times, bring u up a power, and it's u to the -1. Divide by that, and you have 1 over -1. and that's being evaluated from 2 to 10. So this is negative 1/2 times 10 to the negative 1 minus 2 to the negative 1. Or negative 1/2 times 1/10 minus 1/2. Free response, I stop here. Multiple choice, I guess we got to be able to do this. So this is negative 1/2 times 1/10 minus 5/10. Okay, and so that's negative 1/2 times negative 4/10, which as my final answer should give me positive 1/5. Yeah, I think that's right. And that's it for today's lesson. So hopefully that was a sufficient review of U substitution for you. If you need some more review, please pop into Mu Alpha Theta Tutoring once that starts up and get the help that you need. This is homework number 1. As a reminder, homework is due on your test day, not quiz days, but test days. It needs to be turned in order. Meaning homework number 1, then homework number 2, then homework number 3. And the problems within your homework assignment need to be in order to make it easier to check. So if you have a hard time with one, skip it and come back to it. I think that's about it. Thank you.